Hey, hi guys. So in previous session, we have seen collection interface, list interface, array list class and linked list class. And today we will understand the concept of set interface. So under set interface, we have two classes. One is HashSet class and another one is linked HashSet class. So today we will see only HashSet class and linked HashSet class we will understand in upcoming session. So before moving into set interface, we will see the difference between list interface and set interface. Why we are moving into the set interface, we should be aware, right? And when to use list interface and when we should use set interface, we should be aware, right? So first we will understand the difference between both, right? So there are mainly two differences in between both. So as we know, list interface contains duplicate element, but set interface contains unique element, right? And list interface maintain insertion order and set interface doesn't maintain any order, right? So these are the two main difference I have written here, and mostly interviewer ask what is the difference between list interface and set interface, right? So I have written here. So first point I have written here, list allows to store duplicate elements, but set allows only unique element. So in the set, we can store only unique element. If you are storing duplicate element and once you will print it, right, once you will execute, it will take only unique element. It will not take your duplicate element in set interface, right? And in list interface, it maintain insertion order. Why it maintains insertion order? Because here it follow the index value, right? But in set interface we don't have any index concept. It doesn't maintain basically any order because insertion will be happening by using hash code. So in the set interface it will store the value with the help of hash code, right? So that's why it doesn't maintain any order. But list maintains insertion order because here we have index concept. But in set interface we don't have any index concept, right? We will see in the programming, right? So far we have seen the difference between list and set interface. Now we will move into the HashSet class, right? So far we have seen this list interface and set interface difference we have seen, right? Now we will see the concept of this HashSet. So one more thing I will explain you here. Whatever the methods are available under this set interface, same methods will be available under this HashSet class because HashSet doesn't have any specific method. So whatever the methods will be available under this set interface, same methods will be available under this HashSet. So now we will understand what is HashSet. So these are the main points which I have written here. So first point is HashSet stores the element by using hash code. So it is using hash code to store the element. That's why it doesn't maintain any order, right? And second point we have HashSet contains unique element, right? It doesn't contain any duplicate element. It will store only unique element, right? And HashSet allows null values. Yes, we can store null value as well, right? I will show you while programming, right? HashSet class is non-synchronized, means it will not take any backup, right? It is not non-synchronized. And HashSet doesn't maintain any insertion order. Yes, it doesn't maintain any insertion order because here we are storing the element with the help of hash code. So that's why it is not maintaining any insertion order. And here we don't have any index concept, right? So that's why it doesn't maintain any insertion order. And here element are inserted on the basis of their hash code. Yes, right? And HashSet is the best approach for search operation. If you want to perform any search operation, then HashSet is the best approach for searching operation, right? And the last point we have, the initial default capacity of HashSet is 16, right? And the load factor is 0.75. This is a default value, right? Initially, whenever you will create any object like this, right? This is a constructor, right? This is a default constructor, right? Has set, right? This is a default constructor. So if you are not passing any parameter and if you are creating an object like this, so initially default capacity of hash set will be 16, right? So see here, I have created one diagram here so that you can easily understand. So see, initially whenever you will create an object like this, right, then by default hash set will be having 16 location, right? 16 memory location, right? And 0.7 load factor will be there, right? But it doesn't matter this it has filled or not. It doesn't matter your 16 location has been filled or not, but as soon as your load factor will be completed, your memory location will increase, right? Again, I'm explaining you. Whenever you will create any object like this, then by default it has 16 memory, right? By default it has 16 memory and 0.75 load factor will be there by default, right? But it won't wait to complete the 17th element to store. As soon as it will completed the load factor 0.75, it will allocate new memory. And if you want to define your memory location, then how we can define? There are many ways to create an object in HashSet, right? So whenever you will create an object like this, HashSet will be having 16 memory location by default and 0.75 load factor, right? So as soon as this 0.75 load factor will be completed, it will allocate new memory, right? It will not wait for the 17th element. Whenever it will complete this load factor 0.75, it will allocate new memory. But if you want to allocate particular memory, right? If you want to allocate particular memory, then what it will happen? You can define here. So it means assume I have defined 100 memory, right? So if I will allocate 100 memory, it means I can store only 100 elements, not more than that, right? I can store only 100 elements, but still load factor will be 0.75 only because I have not defined here anywhere load factor value, right? I have defined only memory location. So memory location, I can store only 100 element, but still load factor will be 7.5. So if you want to allocate this load factor as well, then we can allocate. How we can allocate? Like this. So assume this is a load factor, right? I have allocated this 0.85. This is a load factor. You can define any value here, but it will be in decimal number only, right? So this is a load factor. Now I have assigned memory location 100 and load factor 85, right? So as per your requirement, you can define here. And if you are not defining, then by default, it will be 16 memory location and this 0.75 load factor, right? And as soon as this 0.75 load factor will be completed, it will increase the new memory location, right? It will allocate new memory, right? Now we have one another way. If you want to store similar kind of data, right? If you want to store similar kind of data, then how you can store? If you want to store any specific data, then we can here define the type, right? If you want to store only integer kind of data, then here we can define the integer, right? And let's see, if you want to store the string kind of data, then you can store the string as well. Instead of integer, you can put string. So same for character as well, right? If you want to store character values, only character values, then here you can pass the character, right? So there are many ways to create an object in HashSet. So far we have seen the these many ways, right? So these are the different ways to create an object where we can configure the initial value and load factor as well, right? This initial value and this load factor as well, we can configure it, right? Just like other collection, we can perform some certain operation in HashSet using these methods, right? So let's understand what all methods are available under this set interface. So these are the common methods which are available under the set interface. So as we already have seen this add all, remove all, we have seen these methods in array list and linked list, right? But we will see these methods in hash set as well. So add method, basically it is used to add particular any object, or we can say element, right? Add all means if we want to add group of element, then we can use add all. If we want to remove particular element, then we can use a remove method. And if we want to remove group of element, then we can use remove all method. Remove if suppose that if any particular element we are giving and might be that element is not deleted, not removed, then I will use this remove if method. So if it is not deleted, then it will delete, right? Contains, basically if you want to search any particular element, then we can use this contains element. It will return either true or false, right? Contains all, if you want to search group of element, then you can use this contains all method, right? And if we want to check whether the hash set is an empty or not, then we can use the is empty method. And if we want to clear all the element, then we can use clear method. And if we want to check the capacity of this hash set, then we can use this capacity method as well, right? So these are the common methods which we use under this set interface. So we will see these methods through programming, right? So as we know, HashSet doesn't have their own method, right? So whatever the methods are available under the set interface, those methods will be available in HashSet as well. But HashSet doesn't have any specific method, right? So now I will create one class and I will show you how we can provide the implementation, right? So I will create one package here with the name of set interface. Set interface. Now I will create one class. Class I will create with the name of HashSet demo. HashSet demo. So now we can see the demonstration part. Now we can create one main method. Yeah, so after creating a main method, we will create one object, right? So how we can create an object? So as we have seen, there are many ways to create an object, but I will create here with the help of this dynamic one. So HashSet. Now we can give the reference variable hs is equal to new HashSet. So now we will have to import it. So here we can import java.util package, right? So we have imported this object, right? So far we have created one object, right? So I told you, whenever we will create an object like this, by default it has 16 memory location and 0.7 load factor, right? So as soon as it will completed the 0.7 load factor, it will allocate new memory, right? So as I already have showed you these many ways, right? So we can utilize all ways right here. So this is the first way which I have commented here. This is the second way where we can allocate memory. Let me change this reference variable name because it is giving an error, right? So you might confuse. Here we can pass float. See, now error has gone, right? This character here will be character, right? So these are the different ways to create an object under HashSet class, right? So this is the first way to create an object. So whenever you will create an object like this, by default it has 16 memory location and 0.75 load factor value, right? And as soon as it will be completed 0.75 load factor, it will allocate new memory, right? But if you want to allocate particular memory, then we can assign here. As you can see, I have assigned here 100, right? So now I can store only 100 elements, right? But still load factor will be 0.75. But if you want to allocate the load factor as well, then you can create an object like this, and there you can allocate the load factor value as well. So you can you can increase the because by default it has 0.75, so you can increase the load factor value here, but it always be in float value, right? And this is the another way if you want to store similar kind of element. So as suppose that you want to store only integer value, then you can define here type. If you want to store only string value, then you can define string here, and if you want to store only character values, then you can define here character, right? So this is the different ways to create an object in HashSet, right? So as per your requirement, you can use any of the object, right? Any of the way you can follow as per your requirement, right? So as of now, I am going to store different kind of data. So I will pick this first one, right? I will use the first one here, right? So now what I will do, I will add some different kind of values, right? So how we can add the values here? So this reference variable dot, I will call to this add method, and here I will add some name. Assume anything I can add it here. So assume I am adding here Java, right? So I have stored now string element. Now I will store character value. Add. I can store the character here. Character I have stored. Now I will store integer value. So integer you can pass anything. After integer I will store float value. Here I will store some float value. After float, I will add some boolean value. Boolean, so boolean returns either true or false. So I will write true here. And as you know, we have seen we can store the null values as well. So I will pass here null, right? Right. See, so I will explain you each and every point, right? So as so far we have seen this one, right? Initial default capacity of HashSet is 16. So whenever you will create an object like this, initial value will be allocated 16 only, right? And load factor is 0.7. So this is the default value, right? This is the 0.75 default load factor value, right? And this is the default memory location in HashSet, right? So whenever you will create an object like this, you will get 16 by default initial value and 0.75 load factor default value, right? So this we have seen. Now we have stored these many values, right? So it contains null value as well. See here, HashSet allows null values as well, and HashSet class is non-synchronized, right? And after that, what it is saying? HashSet stores the element by using hash code. Yes, I will show you. And it is saying HashSet contains unique element only, right? So let me copy and paste, right? Now I want to store this duplicate element, right? See, I'm storing this duplicate element, trying to store, right? But it will not allow. So if I will print these values, system.out.println HS, right? So if I will print, if I will execute this program, see, so it is returning, see, first of all, see, it is saying hash set store the element by using hash code. See, it is using hash code, that's why it is not maintaining the insertion order. Firstly, I have stored this Java, right? But it is returning null, right? In the second element I have stored this A, right? But second element it is returning Java, right? So it is not maintaining any order, right? Why it is not maintaining? Because it is storing the element by using hash code, right? And second point, hash set contains unique element only, right? So see here, Java I have stored twice, right? I have tried to store twice, but here it has returning only at once, right? So it means it contains only unique element, right? And Java, hash set allows null value. See, it is allowed, right? It allowed to store null value, right? This null value. And HashSet class is non-synchronized, means it will not take any backup, right? And we have seen this HashSet does not maintain any insertion order. Yes, it is not maintaining any insertion order, right? Randomly it is printing an output, right? And it is saying HashSet is the best approach to search any operation, right? So if you want to search any particular element, then we can use the contains method. I will show you later, right? And the last point we already have seen, right? So these are the main points which we need to focus in HashSet class, right? So far we have seen till here, right? Now we can see how to remove the element, right? How to remove an element. So if we want to remove any particular element, then how we can remove it? So assume I want to remove this null value, right? Then how we can remove? Hs dot, we can call to this remove method. So earlier we have seen for removing an element there were two methods in a linked list and array list, right? So one we can remove with the help of index value, and another one is we can remove with the help of element, right? But here we have only one method, right? We don't have any two method, we have here only one method. So again let me show you. See, so remove we have only one method, so we can remove here only with the help of element. We don't have any index concept, right? So here if you want to remove any particular element, then you will have to give element name. So assume I want to remove this null value, right? Then I will have to provide here null, right? So after removing null value, I want to check the status. So if I will print this, see, so null has been removed, right? Null was there, it has removed now. Now we can see Java 8, 10.5, 10 and true, right? So null has been removed so far, right? If you want to insert any element in between these elements, then we cannot modify, we cannot, it will not allow because we don't have any set method here. So why we don't have any set method? Because it is not following any index concept, right? So set method is not having, right? But if you want to see, it is saying search operation is the best. right? HashSet is the best for search operation, right? So if we want to search any particular element, then how we can search it, right? So we can search with the help of contains method, right? With the help of contains method, we can perform the searching operation. Searching operation we can perform with the help of contains method, right? So how we can search? So if we want to search, then we can use this hs dot contains. We can call this contains method. Suppose that I want to search whether this Java is available or not, right? Then I will pass here Java. So if it is available, it will return true, or it will else it will return false. So let me system.out.println, right? So if I'll run this program, then it will return true. See, it is returning true because Java is available under this HashSet, right? But if I will put here small j, then it will return false because it is a case sensitive, right? Here I have provided j capital, and here I am writing, here I am searching with the help of this small letter, then it will return false because it has a case sensitive. See, it is returning false. So content should be same, right? So we have seen the search element as well, right? Now, if we want to check whether this hash set is an empty or not, then how we can check? So we can call this method hs.isEmpty method. We have isEmpty method. So if hash set is an empty, then it will return true. Otherwise, it will return false, right? So now it is going to return false because hash set is not an empty. Hash set has some values. See, it is returning false. So far we have seen these methods, right? Add, we have seen add methods, remove method, contains method, we have seen, right? So now we can see how to read an element, right? So here there are two ways to read an element. One is for each loop and another one is iterator method, right? So first we can see with the help of for each loop, right? Reading an elements using for each loop. Here we will not use the for loop because we don't have any index concept, so we will not use for loop. So here we have only two options to read an element. One is for each loop, and another one is iterator method, right? So first we will see using for each loop. For each loop, right? So how we can use for loop, and then see, since here we have stored different kind of data, right? So if I had stored only string kind of data, then I can use here string, right? String, and here you can pass any reference variable, and after that here we can pass the reference variable of this hash set, right? but But here we have not stored only string kind of data. We have stored different kind of element, right? And if you have stored only integer value, then here you can pass here int, right? But here we have passed different kind of data, right? So if you are storing different kind of element, then here we can provide simply object, right? And after that we can print these elements. H object, this is a reference variable, you can take anything. So I'm printing, I'm taking O, and now I will print this. So let me give some message here so that it will be more clear. sys out reading an element using for each loop. It will be more clear to you, right? Once it will print with the once it will print using these masses. See, so it is saying reading an element using for each loop. See, all element it is reading, right? It is printing after reading. So this is the first way to read an element. Now we can see with the help of iterator method. Reading an element using iterator method. Iterator method. So I will create one object. I will create an object for this iterator class. Iterator itr is equal to this reference variable of HashSet hs dot, we will call to this iterator method, right? Now I will put some condition here. So condition will be while loop. So if iterator has some value, then it will move into the next element, right? Sys out. Now here, so once it will check the condition, if iterator has some value, then it will move into the next element, and again it will come into the system.out.println, and it will check if iterator has an element, then it will print and move into the next element, right? So again we can give some message here. So reading an element using iterator method. Now I will run this program. See, it is giving the same output. See, so there are two ways to read an elements. One is by using for each loop, and another one is by using iterator method. We can read all the elements which are available under the hash set, right? So these are the two way to read an element, right? Now we have add all and remove all method, right? So we can see remove all and add all method as well. Now I will create one another class with the name of HashSet demo 1. Again I will create one main method, right? And now I will create one object. HashSet object we can create. HashSet hs is equal to new HashSet, right? Now we will have to import it. Import java.util package. See, so now I want to store only string data. So if I want to store only integer, if I want to store only string data, then we can define here string, right? So if you want to store any specific data, any specific type of element, then you can define type here, right? So I have defined type here. So since I have defined here string, then we can store only string kind of element, right? Object. So now I am storing here, adding here, let's say I am adding Amit here. Now hs dot add. Now I will add here Arun. Hs dot add. Now I will add here Ajay. AJAY, right? hs dot add Amar. So these are the random elements. These are the random value which I have stored here, right? You can store anything, right? You can store integer value, you can store character value, you can store string value. So I have stored here a string value, right? You can store anything, right? Now I will print these elements. I will print these elements. HS, right? See, it is returning right here. So it is not following any order. It is randomly, it is printing this element, right? Now what I will do, I want to execute add all method, right? Then how we can use the add all method? So if I want to use add all method, then I will have to create another object, right? So I will copy this and I will paste it here. So we can say this is a hash set and this is a hash set 1, right? So now I want to add these elements in this hash set, right? So this is a collection of element, or we can say collection of object, which has stored under this hash set, right? Now these collection of element I want to store under this hash set 1. So how we can store? We can, if we want to add collection of element, then we can use like this, add all. Now we can call add all, and here we can pass the reference variable of this hash set 1, means HS. So now all the elements, if I will print this one, sys out, and I will print here HS1, then all the elements which are available here, those will be available under this as well, because I have added those elements, right? If I'll print this, see it is printing twice, because these elements is available under this HS as well as this HS1, because I have added these group of element under this HS1 as well with the help of this add all method, right? So if you want to add any particular element, any other object, then we can add it here. Dot add Rekha, right? HS1 dot add Arya, right? So any of the element you can add it, right? So now I have added this group of element as well as these two other object, right? So if I will add, if I will run now, then it will print these two elements as well, right? So far we have seen here add all methods as well, right? Now we can check how to use remove all method, right? So if we want to remove this group of element, then we can remove with the help of remove all method. HS1 dot remove all method we can use this remove all method, and we want to remove this collect group of collection, right? Group of object, collection of object, we can remove it, right? So after removing, if I want to print HS1, then what it will happen, this group of object will be deleted, only these two object will be remain. So let me run this program, see the output, see. So earlier it was like this, right? Now this collection of this group of object has been deleted, the only remaining object has been available, right? So group of object has been deleted, right? Which was from this hash set HS, right? So likewise you can use add all method and remove all method as well. So far we have seen this add all method and remove all method as well, right? Now we have one more method. So we have remove if method as well. So how we can use remove if method? HS1 dot we can call to this remove if method, This is a remove if method, right? So here how we can remove, I want to put here, you can put here any of the any of the reference variable. Likewise we put reference variable, right? So you can put any reference variable, and then you will have to use this hyphen and this arrow button, right? After that, what we will have to do, we will have to use this hs1 dot hs1 dot contains. So what I want, if I want this, if rekha contains, if rekha contains, then it will deleted. It will delete this rekha, right? So it will check if rekha is available. How we can search with the help of contain? So it will check, it will search if rekha is available, then it will remove it, right? Now if I will print this hs1, then it will remove the rekha as well. See, earlier it was rekha and arya, right? But after this remove if method, this it has searched with the help of this contains method. So rekha was available, so it found, then it has removed in this method, remove if method. So with the help of remove if method, this rekha has been deleted. So it searched first and then it has removed, right? So now we can see the area only. Rekha has been removed, right? We have seen all the methods, right? Add method we have seen, add all method we have seen, remove all, remove if. Contains method we have seen, contains all. If I want to check, then how we can check contains all as well we can see. So if I want to, then I will comment these lines. And if I want to check this contains all, then we can check the contains all as well, right? hs1 dot contains all, and here we can pass this reference variable of this hash set. Now here we can only print sys out. If it contains, then it will return true or it will return false. So let me run this program. See, it is returning true. So this is how we can use this contains all method as well, right? Is empty method, if you want to check the is empty method, then we can check. Now let me uncomment this. So if you want to check the is empty method, then we can use this is empty method as well. So how we can use this is empty method? Sys out hs1 dot is empty method. So it will return false because hash set is not an empty. See, it is returning false, right? Because it has some value. So that hash set is not an empty, right? Now we have this clear method. So now I will use first this capacity. So if I want to check the capacity, then how we can check the capacity? hs1 dot capacity. Okay, capacity is not available. Okay, so we don't have capacity method. We can remove this capacity. We don't have any capacity method. So capacity we cannot check, but if you want to clear this, if you want to clear all the data, then we can use this clear method. So how we can use this clear method? Like this. So after clearing, see, after using this clear method, now if I'll print this values hs1, Then let's see, it will be all clear. See, it has cleared all the element and now it is printing this empty list, right? So far we have seen all the methods, right? Add method, add all, remove all, remove if method we have seen here. See, this is a remove if method we have seen, and then contains method we have seen, contain alls we have seen, is empty method we have seen, and this clear method also we have seen, right? So these are the methods which are available under this set interface, right? And same method will be available under the hash set as well, right? So I hope you understood, guys. And if you still have any kind of issue, then you can ask me in the comment. I will reply you, right? Thank you so much, guys.